Today I'll be solving Leetcode POTD, smallest missing non-negative integer after operations, and this is the POTD for 16th of October. So yeah, let's see. We are given a 0 indexed integer array nums and an integer value. Okay, in one operation you can add or subtract value from any element of nums. For example, nums is equals to 1 to 3 and value equals 2. You can choose to subtract value from nums of 0 to make it -1, 2 and 3. The max of an array is the smallest negative integer in it. Return the maximum max of nums after applying the mentioned operation any number of times. Okay, cool. So first of all, what we can do is obviously the negative integers do not concern our max, so we can just take them away because we don't really care about them, and we have a value. Okay, so thing is that okay, but we can increase the value. Okay, we have to subtract it. Cool. um you can choose to subtract it or add it. Okay, so we'll add it 2 times to 10, so it will become 0, and then we'll have 0 1, and yeah, that's I think that's how we are going to do. So okay, cool. So we need to return the maximum max we can get. All right. Okay, I see. Cool. All right, so the max can never be greater than the length of the array, first of all. So we are going to and we can apply any number of operations. Okay, all right. Got it. Cool. So okay, so what matters for us is the modulo value, right? Because yeah, mod is something that matters to us. And also one more thing that matters, because we are always going to subtract value times something. So we need to think in that direction. Okay, so how do I all right, we need to find the max. All right, all right. Well, basically our requirement is 4. If our requirement is 0, we will need a number that is directly divisible by 5 or its mod value is 0. And if our requirement is basically 1. Okay, one thing I need to see that what is -9 modulo 5. Is it 4? Okay, it's -4. And what is -9 plus 5 modulo 5, it should be a similar value. I mean, it's the same thing, but okay. All right. Well, here's the thing. Yeah. Okay. Okay. So yeah. Mm-hmm. Got it. I think we can do something about this. All we have to do is care about modulo values, then we might be able to do it. So what I'm going to do is I'm going to iterate through the entire array, and then I am going to store the mods. So I'll just store you know I'll just store absolute of x modulo value. And why I am doing this, I'll explain. And then what we can do is well, okay, I'll just explain it here. Well, we are doing this because let's just say that we have let's just say we are searching for, in order to make our max equals to 7, we are searching for a number that is 6, right? So how do we get 6? We can get 6 either by adding adding to minus maybe how can we get it? We can get it either subtracting 5 from 11, so 11 minus 5 is 6, or we can basically get it yeah, or one more way we can get it is possibly by maybe some modulo like -4, right? Because we add 2 minus 4 5, we'll get 1, and then we'll add again, then we'll get 6. So why was this possible? This was possible because 11 modulo 5 is 1, and 6 modulo 5 is also 1. And if we see I think we should get a better modulo value. Mod of negative integers in C++. A modulo n plus n modulo n, yeah, that was that. So it should be x modulo value plus value modulo value, something like this. So -4 modulo 5 is -4, and then we add a 5 to it, so it will become 1. So yeah, that's why it works. So we'll be doing that only for us, and we will just see if we are able to formulate this value for ourselves. And yeah, technically, yeah, that's how we are going to do it. But sometimes just the modulo value is not enough for us, because we can have smaller numbers also, right? So by would like 1 modulo 6 is also 1, but we can make it. Yeah, okay, cool. So this is how we are going to do it. So we'll just say that current max is this. So we'll just go while true if mp.count max modulo value, then we'll just do mp of max modulo. So basically we can find out current equals max modulo val, and then we can just see that if mp dot find cur is not equals to mp of n, then we can just do mp of cur minus minus, and if mp of cur doesn't equal 0, we can just do mp dot is cur value. We can also make this unordered. So yeah, we are going to do it like this, and then else we just break out of the loop. And if that is true, then obviously we did the operation, so we'll increase the max, and then we can just return the max. Maybe this would work, maybe this won't, I don't know. Okay, it gave us a time limit exceeded. Why the hell would you give me a TLE? Okay, so we have 0, we have 1, we have 2, yeah, so we have a 0, we have a 1, we have a 1, so we increase it, we have a 2, we have a 3, yeah, so we have 0, we have 1, we have 2, we have 3, we have 4, then we need a 5, we can get a 5 by this, then we need a 6, we can get it by this, then we need a 7, we can get it by this. I think a better idea would be then we can just increase the max here. Okay. What? Okay. So it is 0. I can just go through the map and I can check. What? Minus 10 modulo 5 is, what is it? 0, and then we add a 5 and then we do mod. Oh, I'm never increasing. Well, that sucks. I wasn't even increasing. How did I give right answer for? Yeah, so that's how we can do this. So it was more like about modulo values, um, negative mods. They're done like this in C++. So yeah, that's all about it. We are checking modulo values because that's what we care about, because we can take a 1 to a 6 by adding 5. We can take a 31 to a 6 by subtracting 5 6 times. So what matters is the modulo value. So we only care about them and if they are present. And this loop only runs for maximum of the length of the array times, because max can never be greater than the length of the array. So yeah, greater than or equals to, matlab, yeah, greater than. So yeah, that's all about this problem.